Hello and welcome to today's webinar, Supercomputing for the Enterprise, Extending Exascale Innovation. The event today is brought to you in partnership with our friends from Hewlett-Packard Enterprise and AMD. Thanks so much for joining us on the webinar today. Before we get started, there's just a few things that you should know about the event. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. We want these events to be educational, and we want to help you to solve your technology challenges. So we encourage your questions there in the questions pane of your audience console. And we even have a best question prize to maybe help shake loose some of those questions that might be on your mind. I'll talk about that more here in just a moment. But first, I want to call your attention there to the Handouts tab. There are some excellent resources available that I encourage you to check out for additional information. At the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card. If you're watching this on demand, of course, that drawing has already occurred. The prize terms and conditions can be found right there in the Handouts tab of your audience console. We also have our best question prize today for an additional $50 Amazon gift card. This is for attendees who ask a question, and you'll be entered into the prize drawing. Of course, prize winners must meet the Actual Tech Media prize policy, and we'll be selecting and contacting the prize winner after the event. All right, and so with that, it's now my pleasure to bring on today's expert presenters. Welcome to MJ Robinson, North American HPC Solutions Business Manager for Hewlett-Packard Enterprise, and Mahesh Balasubramanian, Director for Instinct Product Marketing at AMD. MJ and Mahesh, it's great to have you on the event today. Take it away.
Thank you, David. Hello, everyone. Welcome to this webinar hosted jointly between HPE and AMD. And we are excited to have you here. We're going to talk about supercomputing for the enterprise, extending the technology from exascale all the way down to enterprise scale. And I'll start out from the AMD side. My name is Mahesh Balasubramanian. I lead product marketing for our data center GPU and accelerated processing. And once I'm done, I'll pass it on to MJ Robinson from HPE to talk more about the HPE solutions that form the core of these supercomputing architectures. So I'll kick it off with talking about why we need this exascale class technology. And if you think about it, right, there's been a tremendous bit of innovation on science, on HPC, doing research into astrophysics, clean energy, nuclear physics, etc. In fact, the latest announcements from Lawrence Livermore about nuclear fusion is one such great example where supercomputing is used to help humanity. And along the same lines, machine learning and AI has become a core backbone of a lot of these science simulations that's happening. And if you track the need of these large AI simulations, as I'm showing on the right side chart, the parameter sizes for these AI models are increasing quite rapidly. So the scale I have is logarithmic scale. On a log scale, you can see how quickly the parameter sizes are going up from 2018 to 2022. And to support the research into these large language models or AI models, you need performances from supercomputing class technologies that leads you into these innovation. One such great example that's blowing up right now is ChatGPT. And the amount of supercomputing power needed to keep those ChatGPT servers running and answering customer queries is tremendous. And you can track that on the bottom right chart where we show how supercomputing performance on a log scale has been tracking the needs for these high-end demands for HPC and AI. And over time, we see there's a pretty strong merger of HPC and AI coming together. And it's only going to keep getting, the demand for supercomputing class power is only going to keep increasing. And that's the reason why we need this class of performance technology going into supercomputers from all the way from the big national labs all the way down to the enterprise scale. On this next slide, what I'm showcasing here is, all right, so we understand why we need this technology, but what are the core building blocks to build an exascale class or a supercomputer, right? And I'm bucketing them into four key categories. So one is parallelism, right? So with the amount of compute that's needed, you have to parallelize your problem sets so that you can efficiently and quickly solve these problems. And that's where data center class GPU accelerators come into play, right? A traditional CPU architecture has taken us quite far, And now to take to the next level, you need GPU accelerators. The second piece is data movement. Here now you have a tremendous amount of data. As I mentioned, the parameter sizes for AI are going up crazy, and you have to support them by efficiently moving data between within a node between CPUs, GPUs, memory, storage, networks, as well as within nodes and within clusters through efficient and intelligent network interconnects. And that will help speed up simulation and increase efficiency and power management as well. The third piece is integration scaling. When you build large supercomputers, to maximize efficiency, you need to have an architecture both on hardware and software that takes use of this efficiency of scale, of the large number of nodes and clusters. I mentioned about data movements and how NICs help that. And that is one piece over here where, again, the software and hardware help scale up your simulations such that previously what was thought to be highly difficult is now becomes possible and easy when you can take advantage of these large amount of compute power that you can harness. And the last piece is power, right? You can keep adding tremendous amount of compute power, but the question is how much compute efficiency, but how much power is it gonna burn? And given all the focus on environmental sustainability coming up, there needs to be a power envelope within which we should be able to cater to this amount of performance needs. And that is one of the biggest challenges when you are building supercomputers and exascale class technologies. So what does it take to architect such high performance, right? From a technology perspective, AMD is a vendor there. What do we do to help support these big challenges? So I mentioned about, parallel processing. So on the computing side, you need high performance cores, you need high core count, high memory bandwidth, and the heterogeneous compute where you can now merge CPUs and GPUs together to perform efficient calculation and computing for the largest challenges. And that's one of the core strengths that AMD brings to address these challenges. The second thing on the system architecture side and communication, within a node, you have CPUs and GPUs and sometimes multiple GPUs. The question is, how can you effectively communicate between these and lower the threshold for data movement, management, latency, and increase your throughput? And here, our innovations about, Infinity Fabric links that connect our CPUs or GPUs. And this is something we believe is going to be a foundational requirement to building high performance compute architectures. And then the last point is the interconnect and the topology through which you can reduce your overheads for communication. And the topology also, leverages an underlying fabric, but it has to be efficient in managing data movement across the different compute platforms. And this is where when you're building large clusters, it becomes extremely important that these topologies are resilient and are scalable to solve different problem sets. So now if you zoom out a little bit on, okay, so I understand from a within a node architecture how these challenges can be addressed, but what about on an overall, like the scale of compute that is required across the globe? Our view of how things happen is, you have these big national supercomputers, right? Like Oak Ridge National Lab or Lawrence Livermore National Lab in the US, but they are not a very independent organization themselves. They coordinate and work closely with a very broad set of industries and to help address their challenges. So this is a map showcasing how AMD tries to solve with our technology that is offered into the solution, and interconnecting these various challenges. So as an example, there could be a local weather station predicting how the weather patterns will impact, say, farmers. And they have local weather stations from which they collect information and data through, say, FPGAs, which are highly efficient edge devices. And they can do some local inferencing there, but then the data then gets passed down to our weather supercomputers, where AMD-based CPUs and GPUs working in conjunction with the large supercomputers from HPE can help do some modeling, early warnings, some planning and mitigation, impact analysis, etc. But all this data from various weather supercomputers across the globe can flow into a national supercomputer like Oak Ridge or NCAR, to then simulate what does global warming look like. What are the impacts of this? How does the temperature rise in ocean affect the currents and weather patterns around the world? So that is how the convergence of science happens from various different small pieces to now really address the big problems, and these large supercomputers help solve these big problems. So what are the different pieces that AMD offers to address these problems? As I mentioned, right, we have EPYC and Instinct as data center CPUs and GPUs. But through a recent acquisition, we also have Pensando for data processing unit. So which and then our Xilinx for smart NICs and FPGAs as well. So it forms a very cohesive set of products and solutions that form a backbone of a very efficient and a modern data center. Right? So diving into the Instinct GPUs itself, which we are focusing today, I'm showing three generations of Instinct solutions, MI 100, 200, and 300, all of them underpinned by our architecture called CDNA, or compute DNA is what we call. This is an efficient GPU accelerator architecture, which focuses on using the parallel processing power of GPU architecture for compute needs only. And that's the advantage with which we build world-class supercomputers. So on the MI 200 where we are today, this is what the partnership on AMD and HP is built upon to deliver supercomputers like Frontier at Oak Ridge National Lab, or Lumi at CSC, or Adestra at CINES. So we have a very efficient partnership through which we build these supercomputers, and there are lots of lessons learned. But these are not only applicable to these large supercomputers. This technology flows, and the learning from these flows into everyday enterprise scale, um, you know, high performance computers as well. And we'd love to talk to you more about them. But the partnership doesn't stop there. It goes into the next generation CDNA 3 with MI 300 that we are expecting to launch in 2023. And this is the solution on which AMD and HPE together build the supercomputer El Capitan for Lawrence Livermore National Lab. And for the first time, this is going to be a data center APU. So it's a single package within which we'll have EPYC Genoa cores and CDNA 3 cores in a socketed solution, right? So this is completely revolutionary for this industry. And this is built on partnership with the industry, like Lawrence Livermore National Lab, and with HPE to build the most efficient supercomputers to take advantage of these architectures to simplify how we solve problems of supercomputing class. And that's the hardware piece, but what about the software, right? If you look at on the software side, what we are looking to solve are a pretty broad set of use cases that require high performance and supercomputing class technology. So HPC analytics, AI ML training, and as well as AI and ML inference, large model inference specifically. And I showed you the various solutions that AMD brings as a technology vendor, but it's built upon an excellent partnership with HPE and their servers, and then the software stack goes on top of it. So from our EPYC side, you would see our Zen DNN. AMD ROCm is a software stack for our Instinct GPUs. And then the Vitis AI is for our Xilinx FPGAs. And together, these software stacks support a very broad set of frameworks that I'm showing, like TensorFlow, PyTorch, Onyx Runtime, and then the solution that gets built on top of it, be it the various HPC solutions or AI solutions like GPT-3, ResNet, etc. Right? The benefits of doing it this way, the way to build a stack, is one, this broad portfolio of products that AMD brings becomes very tightly integrated, sharing IP and communicates with each other in a very scalable and efficient manner. And then with the partnership with HPE, we can build the end solution that is best in class for performance, performance per watt, and efficiency. And all of this gets integrated with all the different software solutions available across the market in taking advantage of the underlying software and the technology that underpins, so underlying platform, the technology that underpins these platforms. And that is where you get the scale of performance when you now put together the AMD Instinct GPUs and our software stack, AMD ROCm. On the left, I'm showing a few example AI training performance numbers, GPT-2 for large language model, ResNet for image recognition, BERT again for another recommendation network, again another language model. And on the right, you see performances for industry standard benchmark compared against our competition here. So HPL for LINPACK score for HPC and HPL AI, or what it's called now, the HPL MXP for mixed precision workload from top500.org, and showing not just that on performance does AMD GPUs provide really high-end performance, but also on efficiency too. On the performance per watt, if you look at it, that's twice better performance per watt efficiency And that's a perfect lead into my next slide, which showcases this class of technology combined with the expertise of Hewlett Packard builds these supercomputers like Cray EX that now lead on the top 500 list, right? If you look at the top 500, there are 9 systems which are AMD's EPYC plus Instinct together, all of them built with HPE's Cray systems. And in fact, the first one, Frontier, is the #1 system on the top 500. And along with it, there are 2 other systems in top 10 itself. But the bigger picture is even the Green 500. If you look on the Green 500, 6 of the 10 top systems are all systems built on partnership between HPE and AMD, leveraging EPYC, Instinct, and the ROCm software stack. And this partnership continues on the next level. So as we come up with the next generation solution, look forward to more of this kind of partnership to lead the industry into the next era of performance and performance efficiency. And with that, I will hand it over to MJ to talk more about the HPE solutions and how they provide leadership class performance from exascale all the way to enterprise scale. Thank you.
Okay, thank you, Mahesh. Always good to listen to you. Appreciate the information. Let's go ahead and extend the information here and start talking about the platforms that all of this technology is going to go into and enhance. Before we do that, I just want to mention a couple of things about where we're putting our investments and where the direction of our product line is going, because it is absolutely relevant these days, because the product line from Apollo to Cray has taken a turn. It has made a transition, and it has moved forward in HPE being able to provide exascale technology and supercomputing technology down the chain into the more affordable and more available systems. All right. So we are going to be continuing with our industry leadership, and we believe that this move is a step in that direction. Worldwide service and support will be augmented for these platforms, because these platforms will all be the same. And so for the support that we have with our exascale technology, it will simply trickle down into the product line. The portfolio, because of all of this, has been enhanced. It is more comprehensive, it is more end-to-end, and you will see, because of the innovations that we're making, it is more feasible for customers to implement this technology because of the commonality of management, technology, and performance from the edge all the way up to the cloud. We will maintain and continue to support our flexible consumption models. And of course, all of what I'm talking about here today is a step forward in technology innovation. And I want to mention one other thing too, that when it comes to HPC platforms, we have Cray Cluster Store, and we have several different options for storage, either the large options with the Cluster Store or the smaller options with the parallel file system, is specific to HPC. Our exascale technology, as we have brought the Cray technology into the product line, is now available at any scale and at any size. And this really does offer our customers more choices to be flexible in implementing this technology within their environment. And the supercomputing needs that once used to be only at the top end and used to be for the very large liquid-cooled computers is now moving down to more availability for customers and more options in order to implement at the same type of scaling that we've been able to offer in the past. And let's talk a little bit about those things. Starting from the top down, we have, and people are familiar with, our Cray EX4000 series, which comes in liquid-cooled and air-cooled options. But these are large supercomputing platforms that our customers are buying. However, we wanted to bring this technology down into the product line, and we have made available a couple of different cabinets, starting with the Cray EX2500. The 2500 incorporates the same blades and technology that we see in the EX4000. And we will be looking at a few of these blades moving forward in the presentation. There are a couple of choices here for customers. Looking at the left, we have our EX liquid-cooled optimized cabinets. These cabinets can be assembled as the customer needs them. In other words, They can put in a cabinet at a time as their needs grow within their environment. The cabinets are very dense, up to 64 blades, 512 processors per rack. That is incredible density for this liquid cooled option. It supports multiple generations of CPUs and GPUs within those blades, which make it a very, very good investment for the customer in that when technology changes and their needs change, additional blades can be incorporated without changing out the surrounding infrastructure. It is 100% liquid cooled, and as I mentioned, incorporates a capability per cabinet of about 400 kilowatts. The other option available to our customers is our standard 19-inch rack. It is data center ready, and it is full HPE Cray, software, and Slingshot support ready. The compute nodes are based either on the Apollo 2000 Gen 10 Plus or the 6500 Gen 10 Plus. A typical 2000 configuration is 4 Slingshot switches and 64 compute nodes per rack. So we have good density at the rack level. And again, the customer can add racks as they need them, as their environment requires it. The scaling is from 1 to hundreds of cabinets. This type of technology that I mentioned, from the Cray EX4000 to the 2500 to the standard rack system, all incorporates the same type of scaling, the same type of support, and the same type of HPE experience. Let's focus a little bit here on the blades that will be incorporated into the EX2500. The first blade that will be incorporated into the EX2500 system will be the EX425. It is Slingshot 10 and 11 ready. It incorporates 4 nodes per blade and features the AMD EPYC processor. The next blade that we're talking about is the EX235A. It is Slingshot 11 ready. It is 2 nodes per blade and incorporates not only the AMD EPYC processor technology, but the AMD Instinct MI250X GPU technology. So compute and GPU technology on a 2-node blade. The last 2 blades that I'll mention here are dense liquid cooled solutions, being the 255A, which is a Slingshot 11 ready solution, and the 4252 blade coming soon, which is also dense liquid cooled and Slingshot 11 capable. Now let's transition here from the EX250 to what we are doing with Apollo and how we are transitioning from Apollo to Cray. The Apollo line has served us well, and we are currently today at Apollo 2000 and 6500 Gen 10 Plus. We will be transitioning to our Cray XD product line. The Cray XD product line brings with it the leadership hardware that we have with Cray, that all of which I've spoken about so far with the EX4000 and the Cray EX2500 technologies are all the same Cray technologies. We are going to be extending these technology benefits, including the software and the tools, all the way down into our rack mount server systems. Let's talk a little bit about the systems that will be available. The first system that we are releasing is the Cray XD 2000. We have launched this system already. It will be available first customer shipments in January. It will be AMD powered, and it will be a 2U chassis. This 2U chassis will provide the customer with 2 different node choices, either 4-node dense compute or 2 2U nodes that will allow the customer to incorporate MI210 GPUs from AMD or additional I/O if they wish. This is the 1U server node chassis that we have here. It is 2P, it has loads of memory, and it is very dense. As I mentioned, you can fit 4 nodes into a 2U chassis within your rack. It features the Genoa processor, which will be moving to the different later versions of AMD processor technology, 24 DIMMs, all the newest technology, and also support SSD, all your standard PCI slots, and incorporate an OCP slot. These are things that our customers are used to from HPE within our dense compute nodes. So the technology will be moving faster, forward, and be better, have more features and benefits, and be consistent with the technology that we've talked about with the Cray EX series, both in the 4000 line and in the EX 2500 line. The other option that our customers will have will be the XD295. This, as I mentioned, is the 2U node. And you can fit two of these nodes within this 2U chassis, but it features everything that we talked about in the 1U node. But you think of it as a house, with the 1U node being the first story and the 2U node incorporating a second story, where you can incorporate the MI210 PCI-based GPUs or additional I/O, whatever it is that fits your computing need. Again, all of the same standard features will be available within this chassis at the bottom common level. Now, when we move to the Cray XD2000 from the Apollo Gen 10 Plus, our core count is going to go up. As you can see here, we're going to see increases here in memory. All of our PCI base will move to Gen 5. Memory will be also DDR5, and all of our benchmarks will also see a commensurate increase in performance. Now, what's going to be changing here that is of note? As we transition from the Apollo Gen 10 Plus platforms to the Cray XD platforms, we will see some changes. ILO will no longer be present in these platforms, and we will base our BIOS on AMI and BMC. And this will be more of an industry standard architecture that we see both in our Cray EX line for the 4000 and 2500, and then also within the industry itself. ILO is nice, but we are trying to extend this technology down into the product line. And more importantly, with this new brand, we are trying to make the technology common technology across all of our platforms, common tools to manage, and common ways of implementing the technology within your data center. We will still enjoy HPCM for management, and all of our firmware updates, these will change as well. They will not be included in SPP any longer as they were with the Apollo line. However, Redfish will be taking over this management task. And so as you see here, all of our HP Performance Cluster Manager, Bright Cluster Manager, we have a full set of software components available to these platforms, which again will be common from the XD 2000, 6500, 2500, and 4000 line all the way up the chain. We still will incorporate as well and take very seriously our security elements. So we'll see platform resiliency here with the hardware root of trust. We will still have secure boot with UEFI and our open SSL standard 3.0. Wrapping things up here, we also would like to mention the options that we have for cooling. As technology moves forward and as processors, CPUs, and memory, everything, GPUs, everything gets more dense. And when they get more dense, they use more power and they dissipate more heat. And so cooling is becoming even more important now than it ever has been before. Air cooling here on the left is something that we are all very used to. Also, direct liquid cooling has been very prevalent in the past few generations of product as our products have been more difficult to cool at higher densities. And we will feature liquid cooling for our Cray EX series, both in the 2000, the 6500, the 2500, and the 4000. And this will be processor and memory direct liquid cooling. However, we have some other combinations that could be worked here as well with the rear door heat exchanger, which removes the heat from the rack. And this is an industry standard rack. So ProLiance, Cray XD, all industry standard servers can fit within this rack and benefit from the cooling technology. And then our adaptive rack cooling system, which is a seals rack, uses facility water and removes the heat directly from each chassis that is in the rack. All of these cooling options can be used in combination with each other. We can have chassis that are not liquid cooled installed into the rear door heat exchanger, or chassis that are. And it is the combination of these different technologies that allows our customers to be able to benefit and cool whatever it is that they're putting into their data center to meet the computing requirement at the time. So whether we are moving from the edge to the cloud, having a common technology from the EX series all the way up at the very top down to the Cray XD 2000, and also our edge computing with the EL 8000, we want to make sure that our customers understand that this entire continuum is at their disposal and available from HPE. I want to thank you very much for paying attention to everything here today. And if there are any questions, please don't hesitate to get in touch with your HPE sales teams, and we will help you in any way that we can. Thank you.
All right, great presentation, Mahesh and MJ. Really appreciate that. I learned a lot. I know the audience did as well. I just brought up a poll question for everyone out there. Before we start our Q&A, I want to call your attention to the poll here on the screen. The question is, what are the next steps that HPE and AMD can help you with regarding today's topic? Perhaps you'd like to spend a quick 15-minute conversation to learn more. Provide some case studies, talk about doing a proof of concept, maybe some more education, or do a meeting to talk about how this might meet with your business strategy and outcomes for your organization. All right, so I'll leave the poll up there while we take your questions. And I've brought back Mahesh and Michael here to take audience questions. We've got a lot of great questions coming in. We do want to get your feedback there on the poll while we do respond to these questions. So first one here, I think this one's for you, Mahesh. They're asking, do AMD GPUs have support for CUDA?
Yeah. Thanks, David. Can you hear me well?
Yes, sir. Yep.
All right, that's a great question. That CUDA is pretty synonymous with GPU-based acceleration as a programming environment. And this is an area where AMD takes pride in providing support through our software stack called ROCm. The difference here is ROCm is an open and portable software framework, and we provide tools with which you can convert any code you have written in CUDA to something called HIP. And HIP will run on not just AMD GPUs, but will also run on NVIDIA GPUs as well as CPUs. So it helps take your code, which could be locked to one given vendor, and unlocks it and makes it portable. So yes, if you have a CUDA code, we have a path to convert the CUDA code to HIP and run it on AMD GPUs with ROCm or on NVIDIA GPUs using CUDA.
Nice. You got a lot of flexibility there. I like that. Here's an interesting one for you, Michael. They want to know, so is the Apollo line going away? And is the new Cray XD line really the same technology as the high-end Cray systems?
Yeah, so you can hear me okay, David?
Yes, sir. Mm-hmm.
Okay, so the Apollo line currently is at Apollo 2000 and 6500 Gen 10 Plus. Those will be the last chassis within that line. We made a very we made a decision here to move forward, and based in large part, and Mahesh brought this up in his presentation as well, and made note of it, is that we really do learn from everything that's going on with our customers and all the experiences that they're having. And then also too, the other point is that we were looking at our product line, and we had half and half. So we had the Cray EX series, both in the liquid cooled and water cooled 4000 high-end systems at the top. We had the EX 2500, and then below that we had our large GPU systems with the 6500, and then the large dense compute systems with the 2000 were Apollo. And so we had two different technologies working there. And so what we decided to do, and again, this is based on a lot of our customers' experiences, is we decided to move forward with one product line and then merge the technologies for the 2000 series and the 6500 series to be the exact same technology as our Cray series. So that is the Cray EX 2500 and 4000 chassis. And so with that, it brings a lot of benefits. Having one technology pervasive across the entire line, we manage it, we deploy it, we update it, and everything is done in exactly the same way. And this has benefits up at the top level too, where we support it with point next services, all of our hosting services and financial services. We are dealing with the same technology moving forward. It does bring some differences though, so we will see with the EX series, the XT series, moving forward, we will see that ILO will not be present, and so those will be some changes there that our customers will incorporate, and then also software updates with SPP will not be there, and active health system will not be there. However, all of these things now will be taken over by other components within our software and hardware product line.
Got it. Okay. And I think you just answered one of the other questions that's in the queue here. What happened to ILO? Why is it not present on the new Cray XT systems? Is that right?
Well, I guess I kind of got halfway into that. Yeah. So, getting a little ahead of myself here. So the ILO will not be present. We are going to be moving to a standard management platform that is BMC. We're going to be moving forward with the AMI BIOS, and this is more of an industry standard implementation. And that's going to allow us to have a common server management across all of our chassis, be the 2000, 6500, 2500, and 4000. It's ILO is an HPE specific elegant solution, but we thought that moving forward with something that is a bit more standard with all of our systems, and then also the systems and the management of those systems in the industry would be best. We will also still have HPCM, which as you know, HPCM provides all of our monitoring and management of individual nodes, and it provisions workloads and monitors your health and things like that. And we're going to be building in remote support into that software piece as well. And then at the firmware level, we're going to be providing updates, as I mentioned, not in SPP, but we're going to be working to be having those things automatically and programmatically delivered via Redfish, which we find our customers understand very well as a solution. So that's the answer on that one, David.
Excellent. Yeah, thanks for clearing that up. Another question, this one for you, Mahesh. They want to know, does Instinct have PCIe and SXM cards?
Yes. So there's two form factors we support on MI200. That's with the Cray line with HPE. So these are the MI250. Those are the highest end GPUs. They come in a form factor called the OAM, which is an open accelerator module. It's an industry standard mezzanine form factor coming out of OCP, the Open Compute Project. And it looks very similar to the SXM. The issue is AMD can't use SXM because it's proprietary to NVIDIA, so the industry is coalescing around open accelerator module. And then we also have a PCIe card, and the SKU for that is MI210. That's roughly about half the performance of MI250. So depending on your needs, you can decide to have an MI210 as a PCIe plug-in card, or go to the highest end performance with the MI250 on the OAM form factor.
Got it. Okay. Nice. And here's another interesting one from Gail in the audience, Mahesh, who's asking, how many units can you cascade? I guess getting into the scalability of this solution, how does that work?
Yeah, I wanted to get some little more clarity. So I'm assuming this cascading is a GPU cascading, not a node level cascading. But if anything, I'll let MJ kind of add anything to my comment.
Sure.
So on the GPU side, you can, on the PCIe card, you can go from a single PCIe card up to, depending on the system configuration, you can add 2, 4, 6. You go by basically multiplies of twos to scale more efficiently. And then on the OAM version, on the MI250, on the Cray EX side, you have per node, you have 4 OAMs. And then as you scale it up, then the efficiencies of the NIC come into play, but we have seen quite steady and great scaling efficiency from the Cray solutions with the slingshot NICs. So you have basically, depending on your overall performance need, you can go from anywhere from a single GPU all the way up to thousands of GPUs. As an example, the Frontier supercomputer built by HPE using AMD technologies has over 30,000 GPUs. And that's what gives the Exascale class performance. But you can take that and build a smaller cabinet depending on your, like I said, performance needs.
Mm-hmm. I would say that that's a very, very good answer. And one of the reasons why we scale so well is that we do offer the customer the option to build their environment cabinet by cabinet. And so the scaling has to be there. That's one of the reasons why we moved to the common technology as well that you just mentioned, Mahesh, with the Cray EX, so bringing it further down into the product line, because many of these single cabinets are built upon the Cray X, or will be built on the Cray XD 2000 clusters or even 6500 clusters. And lastly, we will also be building in support for the slingshot technology as well, to make sure that that scaling is further enhanced, just like you mentioned. Good answer.
Excellent. Yeah, thank you. And then another question here for MJ. They're asking, how will chassis be managed going forward? How will clusters be managed as well?
Yeah, so that's see, this is the problem with me reading ahead in the questions, right? Because I'm over here answering bits of the questions and all my different answers. But we will be managing our clusters and chassis. We'll be using HPCM to manage the cluster. Now, with HPCM, we can do the management of the nodes, and we could also do the management of the entire cluster as well. And then we can provision workloads across those nodes. Monitor health, and then get also back the telemetry from the nodes on how everything is working and functioning. All of the readouts that you program into it to be able to get back is answered. One thing that we don't have yet that we are going to be putting in is we're going to be putting in remote support, which was something that Ilo was very, very good at. And then that way we can do all of what I just mentioned remotely as well. The nodes themselves, because they'll be based on VMC, and using the AMI BIOS, they will be using industry standard tools to be able to manage those nodes, just as you would any other interface of that type on any other platform. Firmware will be managed by a Redfish, which is a very well industry standard and very well known solution. And then also one other thing I might manage here, if I might mention here, if I could just take a second, is we still will have one thing that Ilo was good at was providing security, and we will have hardware root of trust in that all of our firmware images that will be managed and installed by Redfish, they will be signed. There will be an identifier there, so if anything doesn't check out at the system level, it will not load. And then also we will also provide secure booting, in that if the BIOS doesn't check out and everything doesn't work and according to what it expects, the processor doesn't identify in the way that it expects to, no OS will be loaded. So all of those standards, including OpenSSL, will be supported in this platform.
Excellent. Great advancements there. And then Mahesh, this one for you. Do you have containers available for PyTorch and TensorFlow?
Yeah, great question. Absolutely. So if you're used to using NVIDIA's NGC as an example, we have something similar on our side called Infinity Hub. So this is the location where all our containers and Dockers are located. So if you're looking for PyTorch or TensorFlow or even HPC applications containerized, so this is where you can go get them and then start running those on AMD GPUs. And if you're, the other option is we are one of the founding members of PyTorch Foundation. So if you go to pytorch.org, you will find the source code there supporting AMD Instinct and ROCm. So you can even build from source if that's your path. So any models that you have built on PyTorch and TensorFlow, once you get the containers installed, should be seamlessly able to run on AMD GPUs today.
Very nice. Well, it looks like we've covered all the questions here today from the audience. A lot of great questions. Thank you, everyone. I want to remind everyone on the event today about the poll question there on the screen. You've just got a few seconds here to respond. We do want to get your feedback on that. Michael and Mahesh, it's been great having you on the event today. I learned a lot. I appreciate all your time and expert presentation here. Thank you so much.
Thank you. Thank you all out there for listening.
Thank you, David. Thanks, everyone. Thanks, MJ.
And thank you to our friends at HPE and AMD for supporting the event today. I encourage you to check out the handouts tab right there. You'll find a link to the HPE and AMD partner resources page. And from there, there's just a plethora of information that you can check out. There's information on HPE ProLiant News, the HPE Cray News, the AMD EPYC Performance, all sorts of resources. So I encourage you to check that out. And if you haven't answered the poll, now's the time to do it, because we do want to thank you for joining us. There again is a link to the HPE AMD partner page. I'll just leave that up while I announce the winner of our Amazon $300 gift card prize. This is going out to Al Ferris from Pennsylvania. Congratulations, Al Ferris from Pennsylvania. We'll reach out to you to deliver some holiday cash. Thank you to everyone who took time out of your day to join us on the webinar. We'll see you next time. Have a great weekend. Bye-bye.